All right, so this session is called Beautiful Abstractions, or Lessons Learned from Reading the Source Code of 18 React Libraries. My name is Yonatan Mevorach. I'm a web developer. I have 2 kids, along with my amazing wife, whose name, and this is true, is Git. And I work for Wix Engineering, where we're early adopters of React, and we have several successful open source React libraries. Recently, GitHub put out their annual Octoverse report, and we were featured there. One of our solutions for navigation in React Native was featured as one of the fastest growing projects. So, in order to learn more about React, in order to learn more about how to write React code that works, I did this task to read the source code of 18 React libraries. And I didn't know exactly what I was going to find, but I hope to get some good lessons out of it. I hope that I would find some common single thread that's available in all these libraries. I even secretly really hope to find something really exciting like that. Maybe all of the popular React libraries are secretly mining your computer for Bitcoin in the middle of the night, but I couldn't find anything like that. So what did I find, and what am I going to be talking about today? So this is an iceberg diagram. Every presentation has to have at least one iceberg diagram. And in our iceberg diagram, when we talk about a library, we have its external API, which is the code that you actually use, that you integrate into your own code. And we have the hidden implementation of the library, which is the code that unless you make the effort to go take a look at, then you don't really have to do it. So when I looked through all these libraries, I found that several of them share, even though they solve completely different solutions, they share the same API that really makes using the library as powerful and as simple as it is. So this is what I'm going to be sharing with you today. And hopefully by reviewing this together, we'll be able to just get a better understanding of the tools that you use, and also get some lessons about maybe these APIs can be suitable for the libraries that you're creating, be it if you're just libraries that you're sharing with your coworkers, or if you're actually going to put it online as open source. So what are the lessons we can learn? One more thing to note, I am going to be talking about synthetic sugar. Some people dismiss synthetic sugar. They say, oh, this is just synthetic sugar, it's not important. But I think that if you're really trying to perfect the API, then synthetic sugar is important, and it's important to get it right. So let's get started with the first library I'm going to be showing you today. This is the only library, by the way, that I'm going to show the entire source code of the library, because it's 33 lines of code. But let's assume that the feature that we have is to implement this, right? So this is Slack. Okay, this might be too much for this talk, so let's just filter this down. Let's say that we have to implement this. So just the online-offline indicator that we have in Slack that tells us if we're online or offline. Well, what would a component that does this look like? It would probably look something like this, right? We would have a component that has state that's going to tell us if the user is online or offline. We need to initialize it. We need to keep it up to date by calling setState at some point. No idea how to do this, but I do know that in my render function, based on this state, I will either render my online or my offline icon. So instead of figuring out how to do this ourselves, let's find a library that will do it for us. This library is called React Network, and it solves exactly this problem. So in order to use it, all you do is it exposes a component called network, and it encapsulates everything in order to figure out if the user is online or offline. I don't have to figure out how to figure this out myself. And in order to use it, all I need to do is pass in this function to the prop called render, and it's going to be called whenever the online-offline status changes with the new status, and then I get to decide what is rendered, because whatever I return from this function, network is actually going to render. So the nice thing about this API is that it totally removes the stuff I don't care about, figuring out if the user is online or offline. But the good thing about it is that it gives me full control about what to render. So it's not like they come with 2 online and offline icons and I have to choose from the ones they choose. I can render whatever I want based on that information. So let's see how this is implemented. And the first thing we need to understand is that actually figuring out if the user is online or offline is a capability of modern browsers. You have navigator.online property that you can check for the current status. And if you want to be kept up to date on when this state changes, you can add event listeners for the online and offline events. So let's take a look at the code of React Network. This is it. Let's go through it one by one. Okay, so first we initialize the state like we predicted, but now we know what to initialize it with the navigator.online property. And this is what we have inside our render function. Remember, we want to let the user decide exactly what he or she wants to render. So because we're using it like this, because they have to pass in this render prop, this is a function. It's going to return whatever should be rendered based on the current online status, which we have, or we already have inside our state. So by invoking this function inside the render function and returning whatever it returns, we're able to achieve this. Now, just to keep this up to date, when the user loses his connection, when the component mounts, we'll add an event listener for the offline and online events. When this event triggers, we're going to call setState with the correct updated navigator.online status. And just to keep things neat, when the component is unmounted, I remove the event listener. So this is pretty straightforward, but this is the basis for a lot of different React libraries. So I want you to remember these 4 parts that we had: initializing the state, adding an event listener, remembering to remove the event listener when the component unmounts, and setting state accordingly when the event listener fires. Because just by changing those 4 parts, we can create completely different components that abstract away other browsers' APIs or other things that we want to ignore. So basically, a lot of different libraries called React, whatever. But let's take a look at a contrived example based on a few real libraries. So here are those 4 lines changed. And now we have a completely different component that supports something similar to media queries in JavaScript. So it will re-render the component that you give it, and it will give it the information about what is the current width of the screen just by initializing this with screen.width and adding an event listener for the resize event. Another simple example, if we want to have a clock component, but we don't want to care about, we want to render whatever type of visual clock that we want, but we don't want to manage, keeping up to date on when the time changes. So you initialize the state with the current date, set the interval, etc. All right. So lesson here, React already takes some of the browser's APIs and gives you a declarative interface that is really easy to work with. And when you need to use a different browser's API that doesn't come already wrapped by React, you can do this yourself. You can abstract away the browser's APIs with your own declarative React components. And if you already take the time to do this, then you can take the extra time to make sure that this component is really reusable and doesn't force you to render anything specific. And this is this idea where we call this headless components. This is where from externally you get the information about what you need to render. And it goes really nicely with the render props pattern. It really encourages reusability. So just a small change to this lesson. If you're not a fan of render props, you prefer things like higher order components or something like that. If you support one, it's really easy to support the other. They're really interchangeable. If you decide in your team what you want to use, you can stick with just one. But if you're planning to put it online for the world to use, then just do yourself a favor and support all of them out of the box. Higher order components, children as function, render props. It's really easy with just a few lines of code if you support one to support the other. All right, let's talk about React Router. React Router is a super popular library. I'm sure a lot of people in this room are using it. And let's figure out how it works under the covers. But instead of just me showing you their source code, what we can do is we can take what we already just created and try to gradually change the code and recreate React Router. And I think it will give us a better understanding of it. So the first thing to understand, React Router is in charge of keeping the URL and the state of our application. If the user hits a certain URL to render something, and so it actually wraps the browser's history API. There's the history.pushState method and events related to this. So let's take those 4 lines that we had before, but adapt them to create our own version of React Router, the router component. I call this the cheap router component, okay, because it's not the real one. But we initialize the state. We care about getting the current location. So we use location.pathname. We add an event listener, and we set state accordingly when that event listener is triggered. So one thing to note about this, you may know this, we're subscribing to the pop state event here. The pop state event is only triggered when the user clicks back in the browser. So if we want this router component to be aware of when the URL changes regardless of any type of interaction, not just going forward or backward, then we need to change this in some way. Now, there is no pop state event that the browser exposes. So what we can do to tackle this, and this is what React Router did, they instead created a different library called history. And what they do there is, instead of calling the browser's native push state event when you want to change the URL, you call browser.pushState, which wraps that. And by doing that, because they have complete control of the way that you change the current location, they're able to provide a different API which is really kept up to date about whenever the location changes. So let's change our example. We're now using this history library, initializing with history.location. And in order to trigger our event handler that's going to call setState, we now use the history.listen method, which they support. So this is pretty good. We already have a component that knows exactly what the location is, so we're pretty much halfway there. But what we didn't change yet, and what we still need to change, is what happens when we render. Right now, we're still rendering based on the render props pattern, and that's not the real API that React Router uses, and let's see why it's not a good fit for React Router. So the reason we even need a router component that's going to be kept up to date on the location is because we have other components like the link component and the route component, which also need to know what the current location is. So if I were to use render props, I would each time I want to know what the current location is, for example, for my cheap link component, I would need to wrap it with a cheap router component and with render props get the location. This can get pretty tedious, especially if I want to have just one router component and I have a bunch of different link components throughout my application. I would need to pass this props down all the way, and it can get really annoying. So let's change this to the real API that React Router uses. This is how we use it. We wrap our application once with the cheap router component, and then anywhere in my application where I have a cheap link component or a cheap route component, I don't even need to pass in the location because it will be able to individually just grab it out of thin air. So let's adapt our code to support this much nicer API. To do this, we're going to use the context API, which lets us read and write data from a single instance that stores it from different components. In order to create a new location like this to save this state, we're going to call create context from React, and we're going to export it from this module. Then we can import it from our cheap router component and change our render method. So this is what we're going to render. The context that we created using the React API exposes this provider component. Remember, this render method is going to be called whenever the location changes. So every time the location changes, in order to save it inside the context, we're going to pass it as the value. But this will actually also render something. Now, remember, this is the way we're calling it. We're wrapping our entire application with the cheap router component. That means that this component gets the entire application as the props.children. So if we neglect to do something with this, then our application won't be rendered at all. This is why we need to pass the children that this component got to the provider. The provider will render that, and this is how our application is actually going to be rendered. So just to complete the example, now this is our cheap link component that actually needs to fetch this data. It needs to find out what the current location is. It again uses the context. There's a component that is exposed by the context that's called consumer, and using render props here, it's quite convenient. We're going to be able to fetch the current location and use it to compose the link or the route. So in cases where an entire subtree of our component tree needs the same data, this is where it really shines and it makes sense to use context. Let's take a look at another library. This is less well known as React Router. It's called React Tracking. I think it solves a really important problem. It's an open source project by the New York Times. And the problem it solves is integrating calls to your analytics software, like Google Analytics, inside your code. Because reporting to analytics is pretty straightforward. You just call some report method usually. But the tricky part is preventing analytics code to be mingled together with your own code. So that when you review your code, analytics is kind of a side effect. You don't want to have that in your mental state when you review the code. This helps remove it and put it really as a side effect when you review your code. So this is how you would use it. Let's say I have a regular React component and I want to report it to my analytics software when this component is added to the page. All I need to do, instead of actually changing its source code, is add this ECMAScript decorator on top. And now this component will be reported when it's mounted. And similarly, if I want to report whenever the user clicks this click me button, instead of changing the event handler, I just need to decorate it with the decorator, and it will work. This is also used by Mobix. They have the observable and computed decorators. So let's take a look at how you create a decorator. This is just a simple reminder of some basic JavaScript principles. Has nothing to do with React, but we're going to need it in a minute. So this is how we define a property in JavaScript. We have our calculator instance here, and we add a property called add, which is a function. This is actually the short way of doing this. There's a much longer way, which we sometimes need to use. We create the instance of calculator, and then in order to add that add property, we use object.define property, passing in the instance, the name of the property as a string, and then we have this descriptor object which we give the value, and also we can set things like writable. If we set this to false, then this property will be read-only. So we are going to need that information in a minute. So I will tell you that a decorator is just a function, but in order to figure out exactly what are the rules of this function, what does it get as parameters when we decorate a method, or what do we need to return, let's figure this out together. So let's do what we normally do when we need to pass in a callback to some library and we're not even sure what are the rules or what's going to be called with. We're just going to console log what we get. So assuming that we take the handle click method that we have on our class component from before and we decorate it with this decorator, let's see what we get. So what we'll get is exactly those three parameters we saw before, right? The instance, the name of the method as a string, and that descriptor object. So let's actually write our decorator now. What we want to do is if we decorate a method, call the real implementation of the method, but before that, report to our analytics software. So we have the target name and the descriptor, and basically, you return a new descriptor from this function, and it can completely change what this method that you're decorating is doing. So we're going to copy over the configurable and enumerable properties from the original descriptor, but we're going to give it a completely new value as what is the actual value and the implementation of the method. And then we'll do what we said we'll do. We'll report it to our analytics software, and we have to do this, otherwise it would really break our code, call the real implementation of the original method that we're trying to decorate. So we're going to call it like this, using the descriptor.value, and by calling it with apply this and passing in the arguments, we're maintaining everything about the original function, and it's going to be triggered in the same way. So decorators, use them with caution because they're not yet a standard part of JavaScript, but they really shine when you want to reduce boilerplate, because the alternative is to have your own code and the library code mixed together really everywhere in your code. It really helps put it as kind of an afterthought that you don't really need to worry about unless you want to read it at that point. Let's move on to styled components. Styled components is a really popular library for styling components. It's a CSS in JS solution. We can learn a lot of things from it. Today we're only going to cover some of them. So this is how you use it. Okay, let's say that we have a element that's going to be rendered as an anchor tag, an A tag, and we want to style it. So what this lets us do is write simple CSS that we normally have inside our JavaScript. This is not unique to just styled components, but you can see here from this example we have this element that's going to be white. Then based on the props that we get, if we get a prop called primary, then we're going to override this color to red, and we also have the border as well. So this is how you would use it. What we get back from calling style.a is a component that we can later use. So here, for example, you see it's based with and without that extra prop that will change the CSS. So I want you to notice something about how we use styled components. Notice that the real way that you use it is similar to the way at the bottom and not at the top. So we're using the backtick operator that we use for template literals, but we're invoking this styled.a function without the normal parentheses that we have when we invoke a function. And here's why. If we were to call it with regular parentheses, and what we'll get as a parameter is the template literal, then our dynamic parts of our style definition, the actual function that we passed over there, the actual code of the function will be converted into a string, and obviously this will not work. We need to keep this as a function. So this is what we actually use when we use styled components, the method at the bottom, and let's see together how it works. So again, just by logging out what we get, let's see how it works. So let's say we keep this example, style.a, color white, props.primary, etc. I will tell you that we can refer to this, the parameters as two parameters. We have the styles array, and then we use the rest operator on all the other remaining parameters, and this is what we'll get. Basically, all of the static parts that we passed in our template will be present in this first array, and all of the dynamic parts, all of those functions, will be at the second array. Now, we know that order is important in our style definition, so we want to keep this in the correct order. What we can do then is we can call the interleave function, which will kind of take one element from each array and in a zigzag fashion kind of merge them together. And what we will get back is this rules array, which actually contains all of the rules that are relevant for this component. But we're not done yet. Now, at some point, this component is actually going to be rendered, and because it's actually being rendered, we know what the props are at this time for this particular component. So we can take this rules array that we had from before, and now we know what the actual props are, so we can call that function that we hold on to, and now we can actually compute the final list of CSS rules for this component. So what will happen if I have two components that both have the primary prop? So if you're already using style components, you know that this is not what will happen, right? We won't have two separate elements with inline styles, because that would be just a waste in terms of performance to re-render this styling information. So what it instead does is it creates a style tag inside the head of my document. It assigns a dynamic class name for this exact list of rules, and then it just assigns that class name to all the elements that it creates. In order to do that, once we have that list of final rules for this particular element, we hash them. This gives us the name that we use. We check if this name has already been used before, and if not, we call stylesheet.inject using that name, that hash result, as the class name also, and injecting that CSS into the head. So notice that what we're doing here is we're actually calling document head.append. So it means that even though the user just rendered this regular React component somewhere inside his component tree, if you're not aware of it, what happens is that styled components goes somewhere completely different in the DOM than where you expect and adds something to the head. This creates a really seamless experience when you're using styled components, but if you're a library author thinking to do something similar, you need to do this with a bit of caution, because once you start communicating directly with the browser API and communicating directly with the DOM, you know, this is 2018, people assume that the React code that you put out as open source will work everywhere, not only in the browser, but also if you're doing server-side rendering or React Native. So what styled components does, and a lot of other libraries that do this, they check what is the environment where you're running and fall back to a solution relevant to that environment. So this idea of using the template literal, you know, with the backtick and putting my CSS inside with my JavaScript, but still making it very readable. These are called tag template literals, and they really make sense where you need to incorporate any domain-specific language along with the JavaScript code. CSS is just one example. Apollo client uses this for integrating GraphQL queries inside your JavaScript as well. So if that's the case, it's a powerful tool to have. And also remember that you can escape out of the React rendering context, but like I said, do this with a bit of caution, because you need to realize that you're assuming the responsibility for how this component is actually going to be used. So just to wrap up, you know, we're very privileged in the software community, especially in open source, where we have so many open source tools. If you're in hardware and you want to understand how something works, you basically have to break it. But for us, reading the source code is really easy, so I encourage you to do it and try to take a cue from the libraries that you use and be inspired by their APIs to create better APIs for your libraries. Thank you very much. If you have any questions, catch me later. Thank you.